The legumes, Unit 5. Legumes are members of the pea family and include peas, beans, peanuts, vetch, mesquite, honey locust trees, and many, many more plants. The legumes have typical characteristics. If you see these characteristics in a plant, you can be almost certain that you're looking at a legume. They have either pinnately or palmately compound leaves, most of them. They have bilaterally symmetrical flowers. We'll take a look at that in a minute. The fruit of a legume is born in pods, and the pods contain a single row of seeds. The seeds happen to be high in protein. And many legumes have the ability to convert free atmospheric nitrogen into a form that can be used by plants to make proteins. We'll also take a little closer look at that. Here we're looking at a typical legume flower, and as I said, they're bilaterally symmetrical. That means that if you cut them in half, one way or the other, the halves are going to mirror each other only in one direction. So notice if you cut this flower top to bottom, this half mirrors this half. But if we cut it in half sideways, this bottom half has no mirror image at the top. That's what we mean by bilaterally symmetrical. Orchid flowers are similar. Down below you can see a typical fruit. These happen to be peas in a pea pod. You have a single row of fruit or seeds arranged in a pod, and that's typical of almost all legumes. Legumes are extremely high in protein and have been called the poor man's meat, so they can fix atmospheric nitrogen into a form that plants can use. They're high in protein. It's not all good news, though. Many legumes, certain beans in particular, contain certain alkaloid compounds, which may increase the incidence of anemia. And in certain Mediterranean areas where large quantities of broad beans are eaten, there is a higher incidence of anemia. Here we can see a collection of various legume seeds, and you can see they come in a huge range of sizes and colors, from quite small here to quite large, colors from white to purple, green, orange. However, if you look at the fruit that all of these came from, it would be a pod with a single row of seeds. Here we're looking at a much magnified image of nodules on the roots of legumes. The legumes that produce these nodules have a symbiotic relationship with a bacteria in the Agrobacter family, that these bacteria are the actual organisms that fix the atmospheric nitrogen. What that means is that atmospheric nitrogen, or nitrogen in gaseous form, is N2. It's a molecule of two nitrogen atoms together, is not useful for plants. Plants have no ability to take that nitrogen from the atmosphere and make use of it. And nitrogen is the primary nutrient in the macronutrient range of fertilizers. So plants need a method of getting nitrogen in a form they can use. Well, the legumes have developed this symbiotic relationship with bacteria. The bacteria live protected in these nodules on the roots of legumes, and they convert the nitrogen into a form that plants can use. Fortunately, for other plants, they convert more of it than can be used by the legume that's growing, so the net result is an increase in available nitrogen in the soil. There are natural sources of nitrogen in the soil in areas where there are no legumes, for instance, adding nitrogen to the soil. How do plants grow? Well, they make use of natural sources. In the atmosphere, the air we breathe is 78% nitrogen, but most of that nitrogen is not available for plants. However, when lightning strikes, the temperature and electrical conductivity of the lightning converts a small amount of the nitrogen in the atmosphere to ammonia and to nitrates. That falls to the ground and is available for use by plants. Volcanic activity is another natural source because volcanic gases contain ammonia. In addition, nitrogen can be fixed in the soil by bacteria that don't necessarily live in legumes, and we'll take a look at the nitrogen cycle. At the top, we see that we have nitrogen in the form of N2 that is not available to plants in that form. Plants have no ability to make use of that. However, there are some bacteria, denitrifying bacteria, which live in the soil, which have the ability to convert that nitrogen into nitrates, which is a form that plants can use. It goes right into the plant roots. Another source is animal waste, dead animals themselves, plants that are dying and decaying in the soil. They're both broken down by these decomposers, primarily fungi and anaerobic bacteria. That converts the nitrogen stored in those organisms into a form of ammonia. Then the nitrifying bacteria convert that to nitrites, which are then converted to nitrates and follow the same path and can be used by plants. Finally, we have the nitrogen-fixing bacteria on the nodules of the legumes that can take this atmospheric nitrogen directly and turn it into the same ammonium that the decomposers make, and then allow it to follow that cycle around. So legumes can be an important source of additional nitrogen in the soil for plants other than the legumes themselves to make use of.